Okay, guys. So this is regarding the CSV data cleaning section. So before going to that, I'll try to explain a couple of concepts like normalization and scaling. We'll come to scaling later. What you need to understand first is normalization of data. Now, before going to normalization of data, I'll first, because I'm not going to deep into SQL and other stuff, but I'm going to use the concepts of SQL, not technically. So that'll help. For example, there is a data set which says, mm, for example, a patient profile. Now, there is a data set of healthcare sector in which it says patient name. Second comes the patient disease, obviously, doctors assigned. Then comes your his lab reports. After that, I'm just trying to make a data set of at least 9 to 10 columns so that I can have more cases to explain. So in this, let's say I'm adding in place of lab report, then I'm going to keep lab name. Then I'm going to keep lab name, credit card used for payment. Then I'm going to use write the insurance company name, plan name. So just by looking at it, I can tell this thing gives you a rough idea about a patient's profile in a particular hospital. But you see, this particular data has dimensions in it. Don't go into the term dimension technically. I'm just asking you, dimension. What is dimension? Dimension is this is one dimension. A dot moves. This is a one dimension. This is two dimensions. A guy moves either this way or this way. These are two dimensions, which means there are two ways of. So if there is a point, we obviously write x and y coordinate, which means there are two perspectives to see that point. One through x, which is basically this distance, and one through y, which is this distance. Likewise for three dimensions. So don't go into the technical details of what dimension is. Dimension is basically, if we, if you have to explain someone in a very layman language, is basically a way of describing a point. So here, if someone is asking us, this full data is about a patient, but we see only the name of the patient and the disease and his lab reports. These are his three personal points. These are the three personal, I would say, KPIs, which would basically explain a patient individually. So I would take, let's say, I will try to split the CSV into. So I would say a patient CSV should look like, I'm doing this hodgepodge. Okay. So I'm doing this patient CSV with the columns. First of all, for every CSV, an ID column is like absolutely mandatory. I'll come to that later why. So ID, name, disease, and lab reports. Now lab report can be positive. It can be a file, another PDF file acting as an attachment over here. So if you want, you can ignore lab report because I feel these three are sufficient. I'll just take out lab report from here. This would make things complex. Now, second dimension, what I see here is doctor. Because, for example, there is a hospital in which there are like 200 patients and there are just 10 doctors to attend. So if you're going to fill this information for 200 patients, for sure there is going to be some, I mean, the doctor name is going to be repeated. There are 10 doctors who are spread over 200 patients, so obviously doctor names is going to be repeated. And there can be a second info as well here. For example, doctors specialization. So these two things are going to repeat throughout, which will create a redundancy. I'm I'm again saying do not go into the technical details. I'm just going through the layer of it so that you guys explain that the basic thing to design or model any data mart or any small CSV in, I mean, any data in this form of a CSV is to first break it. And when you break it, why do we break it? So that we can avoid as much redundancy as we can. For example, here there can be only one patient with one patient. I mean, for example, if there obviously there can be two patients with the name Vivek, but if we talk about with perspective of one patient, then these information, disease, and other stuff will belong to him only. So this depends on this. This is called maintaining integrity, data integrity. Now coming on to doctor. So for doctor again we'll have an ID for doctor. Then we'll have doctor's name and his specialization. This is the second profile. This is the second CSV, which we second dimension you can also say, which is doctor and doctor's specialty. Third dimension I see is lab, because there is lab name over here, and I would say what I ignored here. So I would say lab name. So let's say a lab.csv, which again has an ID, lab name, and another KPI so that you doesn't confuse you. So let's say branch. So branch is as in, for example, we are talking about Apollo Pharmacy. Now Apollo Pharmacy has more than one branches in Bangalore, so it can be any branch. So I'll keep another CSV which would go by the name of lab, which again have ID, lab name, and branch. So this way we are done with these two. Now we are left with credit card, insurance, and plan name. I can add one thing again here, credit card type. Now my third CS fourth one two three fourth CSV would be credit card.csv, which will again have the ID. The credit card name is basically the bank name, and the credit card type would be Visa, Master, whatever, right? So that way we cover this as well. And final is insurance company name and insurance plan name. So that would become our fifth dimension, which would be insurance.csv, which would again go by the ID, insurance name, and insurance plan name. So this name can be anything, for example, Cigna, and plan name can be anything, like for example, Open Plan Plus, something like this. So that's how you basically normalize the data. This type of normalization is called BCNF. Okay, I'll not go into technical details. Just this is the basic normalization of data in which you break data into various dimensions. Now, this full information we can see through five perspectives: patient.csv, doctor.csv, laboratory.csv, credit card.csv, and insurance.csv. I'll come to the next. I'll explain later in another video so that you guys do not get bored. So I'll just cut the video here itself.